Sorry, James.
And if I go to this side, coordinates are negative 1, 0. A little bit. And the bottom's 0, negative 1. I love that I have a door closer. Love it. Because I feel the same. Shut up. So this is where you're going to go next year, but you don't need to know this year, but it just makes sense in my head to explain it. Imagine I had a circle that joined these points. Imagine it was circly and not eggy shaped like that. That's called the unit circle. That's that tiny circle that I was talking about next year you're going to meet. That's where it's coming from. It's one unit in every single direction. What it allows us to do is to get the sine, cos, and tan of those 4 angle values without our calculator. So we know this is 0 degrees, and the top of the circle we know is 90 degrees. And what about the other side of the circle? 180 degrees. And the bottom is? And if I come all the way back around, I know 0 is the same as 360. And because this is a little circle, which again I'm not really going to talk about till next year, but just get the idea it's a circle. What's the radius of this circle? 1, because I chose to do it 1 unit in every direction. So just keep in your head that 1 is the radius, which would also be the hypotenuse if I draw any point and did that right angle triangle. So if we just look at these formulas here, because this is 1 and 1, what do I know that cos is really equal to? It's the x-coordinate of any point is the cos value of that angle. And what's the y value equal to? The sine. And we can take tan by taking those 2 coordinates and just dividing them. So what that allows us to do is just by knowing these coordinates is we can get the sine, cos, and tan for every single angle. So follow the logic here. I'm going to start at the top of the circle. Sine of 90 degrees is equal to the y coordinate. So sine of 90 is equal to 1. Grab your calculator. Punch in sine 90, enter. What do you see? It's 1. That's what the calculator is doing. It's imagining this little circle and imagining that it's got a radius of 1 and it's doing that calculation for you. If I do the cos of the top of the circle, cos is equal to the x-coordinate, so the cos of 90 is 0. Punch in cos 90, just check with your calculator, is it 0? The tan comes from dividing the y by the x, because that's just from this formula here. So if I take tan is going to equal to 1 divided by 0, what happens when we divide anything by 0? It means it's undefined. So do tan 90 and you should get an error on your calculator. So the trick for this is really just memorizing these little formulas that sine is always the y-coordinate, cos is always the x-coordinate, tan is always the division. I remember alphabetically. What comes first in a coordinate pair, x or y? X. So x comes first before y alphabetically. What comes first, cos or sine? Cos comes first alphabetically. So I always remember that cos theta is the x-coordinate and sine theta is the y-coordinate by alphabetical reasoning. Tan you just need to know is y divided by x. I'm going to go to the right hand of the circle, right-hand side, left-hand side of the circle. Let's try that again. So we're going to get the sine of 180, the cos of 180, and the tan of 180. It all comes just from the fact this is the point negative 0, 1. So the sine value has to be 0. The cos value has to be. Then divide the y by the x value. 0. Check those on your calc. Make sure that they're good to go. So check sine 180, cos 180, tan 180. Bottom of the circle, tan 270, or sorry, cos sine 270 first, cos 270, tan 270. sine of 270 is the same as the y value, so it has to be. Cos is the same as the x value, so it is. And tan comes from dividing the y by the x, undefined. And then we can do the same thing. It doesn't matter if you use 0 degrees or 360 degrees because they're the same spot on this little circle that we're not supposed to talk about. Sine is always the y value, so the y value of 360 is. Cos is always the x value at 360 is. And tan it comes from dividing the y by the x. 0. That's the theory. The practical piece is you need to memorize these values. You need to now know the sine, cos, and tan for 0, 90, 180, 270, and 360. The y really won't matter till next year. Just know you need to memorize them. How are we doing so far? I'll take a minute right now. Then we're going to talk about something called special triangles. There are 3 special triangles, which are like, what? You drew 2? Because we use this diagram for 2 of the triangles. So the special triangles come from having an angle of 30, having an angle from 60, and having an angle of 45. By the end of today, you have to memorize the sine, cos, tan of those 4 angles we just looked at, the 0, the 90, the 180, the 270, and the 30, the 60, and the 45. And I'm going to give you tricks to memorize, so don't panic. That's your homework. There's no actual questions. It's just memorization. So when you come in tomorrow, you need to know 0, 90, 180, 270, 360, which is the same as 0, your 30, your 60, and your 45. What that allows us to do, if we flip the page in a second, is do the exact same questions as yesterday without a calculator. We can do it, we can do it. Don't make that face. It's not that bad. Don't make the face. Don't make the face. So we call this a 30-60 right angle triangle for obvious reasons, because if one of the angles is 30, the other one has to be 60. Why? Because it equals 180. If we used up 90 and we used up 30, the other one has to be 60. Yes. Well, kind of. So the properties of a 60-30 triangle is that the shortest leg is always half of the hypotenuse, or the hypotenuse is double the shortest leg. What's the leg of a triangle? It just means the side. So which one of these has to be shorter? Is it the one opposite the 30 or the one opposite the 60? It's opposite the 30. So the special of a special triangle is if this is 1, this is 2. If the leg was 2, the hypotenuse would be 4. If the leg was 10, the hypotenuse would be 20. If this was 1,000,000, the hypotenuse would be 2,000,000. That's the properties of a 30-60 triangle. The shortest leg is always half of the hypotenuse. Let's calculate the last side. So I'm going to put an x because we don't know what it is. So let's calculate it using Pythagorean formula. So I know that x squared plus 1 squared has to equal 2 squared. X squared is going to equal, I heard a quiet little offer of 3. And then how do I get rid of the squared? I square root it, and I just leave it as the root. I don't get the decimal value. So that's always the third side of a 30, 60, 90 triangle, we call it. Are you with me so far? So let's look at the sine of 30, the cos of 30, and the tan of 30. To memorize these, it goes straight back to SOHCAHTOA. You're just looking at the ratios of the sides. So sine is what side over what side? Opposite over hypotenuse. So opposite the 30 is 1, hypotenuse is 2. Remember yesterday when we were dealing with that cast thing and I was like, okay, calculate the sine, cos, and tan of 30, and then we did all the other angles that are its reference angle, and you got 0.5. This is why it was 0.5, because it's a 30-60 triangle and it's 1 over 2. Okay, SOHCAHTOA, cos is adjacent over hypotenuse. What's the adjacent side to the 30? oops, square root of 3. That's a 3, but it's all smudgy now. And the hypotenuse is 2. Tan is what over what? Opposite over adjacent. The opposite is? The adjacent is? But wait, we need to rationalize that because we don't like leaving that with the root on the bottom. Way back to Unit 2, rationalizer. How do we rationalize? Times by root 3 over root 3. Top becomes root 3, bottom becomes 3. You need to memorize that sine of 30 is 1/2, cos of 30 is root 3 on 2, and tan is root 3 on 3. I'll give you some tricks in a second, so don't panic. Now we're going to use the same diagram, we're just going to do it for the 60. So now we're going to switch what is O and A. So we need to know sine of 60, cos of 60, and tan of 60. Sine is what over what? Opposite over hypotenuse. Now we're going from the 60, so what's the opposite side to the 60? Root 3, hypotenuse is 2. Cos is adjacent over hypotenuse. What's the adjacent side? 1, hypotenuse is 2. Tan is the opposite over adjacent. The opposite is? And the adjacent is 1. And we would never write root 3 divided by 1. What would we write that as? Root 3. You need to memorize by tomorrow that sine of 60 is root 3 on 2, cos of 60 is 1/2, tan of 60 is root 3. I'll give you tricks in a second, don't panic. What do you notice here about the sines and coses of 30 and 60? They're flipped, right? So they become each other. That's because we're working from the same triangle. How are we doing so far? And I'm still good if you're like, This is our second special triangle. Well, they call it the third, but I call this 1 and not 2. Second, third, whatever. It's the other special triangle, and it's called the 45, 45, 90 triangle. What kind of triangle has two angles that are identical? It's an isosceles, and really to kind of see the isosceles, I'm just going to turn it this way because that's the way we're used to seeing it. So what it means is these two legs are identical because it's isosceles. The details of an isosceles triangle is if these are both 1, we need to figure out what the hypotenuse is. How do I figure out the hypotenuse? So 1 squared plus 1 squared equals x squared. So 1 plus 1 equals x squared. X squared equals 2. X is square root of 2. So the three legs on a 45, 45, 9-angle triangle are always 1, 1, and root 2. Same deal as before, we need the sine, cos, and tan of 45. Well, which angle am I using to determine opposite? It doesn't matter, they're identical. You can use this 45 or this 45, it doesn't matter. I'll use the one on the bottom for no reason. What's the opposite of this 45? 1, hypotenuse is, but wait. Kate? So it'll be root 2 over 2. Cos of 45 is the adjacent over the hypotenuse. What's the adjacent? 1. What's the hypotenuse? Root 2. But wait. Root 2 over 2. What do you notice there about the sine and cos? The tan is the opposite over adjacent. Doesn't matter which angle you use. The opposite is. And the adjacent is. And 1 divided by 1? 1. I'm going to pause there. There's a pink sheet up on the table. You're going to grab the pink sheet and you're going to grab a pair of scissors.
Sorry again, James.
We want the quadrants where sine is positive. So if you need to see the cast rule, write the cast rule. Where is sine positive? How do I get an angle in quadrant 1 if I have a reference angle of 90? We add it to 0 or add it to itself, so it's going to be 90. How do I get it in I almost told you there. How do I get it in quadrant 2? 180 minus, which is also 90. Do you need to write it twice? No, the answer is 90. Look at what you're doing without a calculator. You're so smart. Seriously, Essentials kids would cry if you showed them this. B. Cos theta negative root 3 on 2. Root 3 on 2 tells me it's one of those fancy fractions. Okay, so I know I'm going to either my special triangle, my ratio, or my trig, or my table. Whichever one works best for you, you think so far, open the door. If you were like, ooh, table method, I like that, open that door. If you were like, ooh, ratio method, pick whatever method right now is going to work best for you. If you're not sure, randomly pick a method. What we're looking for is what is the angle value that has a cos of root 3 on 2. We had an offer of 30, confirm. Oh, we had an offer of 60. 60 or 30, find it out. Yeah, we want to look at cos is root 3 on 2. Confirm of 30. What quadrants do we want? Where does 2 and 3 come from? It's negative, so it's not quadrant 1 and it's not quadrant 4. Now we just give the angles. How do I find it in quadrant 2 if my reference angle is 30? These should be able to be done non-calc because they're not weird numbers. It's 30. So 180 minus 30, for example, we expect you to be able to do. 180 minus 30. And then quadrant 3, 180 plus 30, 210. Show me your thumb so far. I'm okay. Good. And I'm okay sideways right now. Sine theta, root 2 on 2. Funky fraction. If the method we just picked did not work for you, try another door. Pick another door. Pick whichever one works for you. Whatever method works for you, I would write that on scrap paper, write it right on your test or quiz so it's visual and it's in front of you. We are looking for where is sine root 2 on 2. Offer of 45. Quadrants. How do I know what quadrants I'm picking? The sign of the sine. Sign of the sine is positive. Where is sine positive? 1 and 2. In quadrant 1, theta is going to be? In quadrant 2, so 180 minus 45. 135 with a question mark on the end. D. Because it's 1, it's not a funky fraction or a radical, it's going to be an axis value, so we need to come over here and figure out where is tan going to be equal to negative 1. So what I do is just go around the circle. 0 divided by 1. Is it 1 divided by 0? 0 divided by negative 1. Negative 1 divided by 0. Where do I get tan equal to 1? Yeah, it's not one of these, but it's what your brain is going to think because those are 0 1s. If this doesn't work, go back to your other method, table or ratio or triangle. Which angle has a tan of 1? 45. What quadrants do we want? 2 and 4. In quadrant 2, we just did in the last example. And in quadrant 4? 5 minutes, turn and talk with a friend, do the 4 that are left.